Hi Zach, I received your quiz from Mr. Garris and just wanted to go over a few things here. The first question is giving you an equation, and I wrote it up here so you can see it a bit better. It's giving you the equation f of x is equal to 2 sine 4x minus 180 degrees plus 1. And you're to state the amplitude, the period, and then sketch the function. You said that the amplitude is 2, and that's absolutely correct. The amplitude is 2. And we get that from this value here, the number that's being multiplied by our sine function. The period, however, we determine by looking at this number here. What I want you to watch for is find the number that's being multiplied by your variable. Your variable is in brackets, but you can see sort of indirectly that this number is being multiplied by x. We use that number to determine the period. If you consider sine x looks like this, as you know, because you did a good job sketching it. And it has a period of 360 degrees. Because when you do a full rotation, the cycle for generating sine x repeats itself. So by default, the period for sine x is 360 degrees. When we multiply that by a number, that increases the frequency, meaning we get more ups and downs in the same amount of time. So if we multiply x by 4, the effect that has on the period is it divides it by 4. So if I was to plot the sine of 4x, I would have, over 360 degrees, 4 up and downs as opposed to just 1. 1, 2, 3, 4. So that number 4 means we have 4 times as many cycles in the same amount of time. So the effect that has on the period is the period ends here. It starts here and it ends here. So the period for the sine of 4x, or any more complicated function where 4 is the number that's being multiplied by x, the period is 360 degrees divided by 4. And 360 divided by 4 is equal to 90. So what we're looking for here is a period of 90 degrees on this. Let me just take you through what all these numbers mean. As you got correct, the first number determines the amplitude, and in this case our amplitude is 2. The number that's being multiplied by x determines the period. Use 360 as your default period, and then divide it by whatever number is here. In this case, it takes that 360 divided by 4, gives us a period of 90 degrees. The number that's being subtracted from our variable inside here is our horizontal shift. In terms of periodic functions, we call that a phase shift. Phase, P-H-A-S-E. That's phase, and what that amounts to is a horizontal shift. Now, because this is a periodic function, it repeats itself every 90 degrees. It's a periodic function with a period of 90 degrees, so it repeats itself every 90 degrees. So if we shift over our sine function by 180 degrees, we're shifting it over 90 and then shifting it over by another 90, you'll actually see no change. So this being a perfect multiple of the period, it's going to have no effect. And finally, that plus 1 just means that we shift everything up by 1. So to plot this, what we wanted to do is grab some paper here. I find the easiest way to plot these is to just draw your function. You know what sine looks like, and then we fit in the axis afterwards. So sine looks like that. There's no horizontal shift because we're shifting an exact multiple of our period. And our period is 90 degrees. And this was shifted up by 1. because it was shifted up by 1, I'll just move the axis down by 1. Our amplitude is 2. So if the axis comes down by 1, it's going to go as low as -1 and as high as +3. That gives us a distance from our rest position of 2. See, we go 2 above the rest position and 2 below the rest position. That's what the amplitude means. Our period, this repeats itself every 90 degrees, so I can put 90 degrees in here, or over here at the halfway point, I could put 45 degrees. And that's the full plot of 2 sine 4x minus 180 degrees plus 1. Okay, the next question on here gives you this graph, and it's asking you the amplitude, the period, the horizontal displacement, the vertical displacement, and then to write down the equation. From looking here, this goes up to 1.5 and comes down to -2.5. So the total distance from peak to peak on question 2 the top is 1.5 and the bottom is -2.5. So the total distance from top to bottom is equal to 4, which means that the amplitude, which is always half of the peak to peak distance, the amplitude is going to be 2. The period, that's how far over we have to go for the cycle to fully repeat itself. See how it starts here, the rest position is down here, and we get back to the rest position here. It's a bit less than 200 degrees, so the period here is equal to 180 degrees. Now, you can't really tell that it's exactly 180 degrees from looking at this graph, so anything near there that's reasonable I would accept. So if you were somewhere between 170 degrees and 190 degrees, you should be able to see that it's a bit less than 200, as long as you're reasonably close, given a graph of this resolution. So our period is 180 degrees, our amplitude is 2. The horizontal displacement. Now, the horizontal displacement depends on, when you're looking at this, if you consider that a sine curve or a cosine curve. If you consider it a cosine curve, it starts at the top, and we would say this was shifted to the right, and we'll read off the graph however far this was shifted over to the right. If you consider this a sine curve, it was shifted a little bit to the left, because it's starting down here. So it's a bit arbitrary as to which one you choose to call that. Now if we take a close look, that's 200 when we go 1, 2, 3, 4 ticks. So each tick is 50. So that tick is about 50. So it looks like we have cosine shifted 50 to the right. So I'm going to say my horizontal displacement is 50 degrees right. And our vertical displacement, I think that's the most obvious here. We have an amplitude of 2, but only gets to a height of 1.5, not to a height of 2, which indicates to us that the vertical displacement is minus 0.5. Now I want to put all of that information together to write down an equation. I'm using cosine because that looks easier for me based on looking at this. Because cosine starts at the top. So remember the cosine of x, if we were to just look at cosine of x, it starts at the very top, makes its way down, makes its way back up, has a period of 360 degrees. It starts at 1 and it ends at -1. So I have to do transformations to that to meet this criteria here. To write down the equation, I'm going to start out by saying that we have an amplitude of 2, so it's y equals 2 times the cosine, and now I need a number here that's going to give me a period of 180 degrees. Remember, by default, cosine of x has a period of 360 degrees. I want to divide 360 by 2 to turn it into 180. So that's going to be the number 2 that gets multiplied by our independent variable. I want to shift it 50 degrees to the right. Shifting it to the right requires subtracting that number from the variable directly. So I'm going to subtract 50 degrees from x. You'll always have this double bracket when there's a change in period and a horizontal shift. And finally, we have to shift it down by 0.5. So I'm going to put minus 0.5 here. And that's writing down the equation that perfectly matches this graph. We have an amplitude of 2. That's that 2 there. We have a period of 180 degrees. And we get that period by multiplying x by 2, because that takes 360, divide it by 2 gives you 180. To shift it to the right by 50 degrees, we're subtracting 50 directly from x. And to shift it down by 0.5, I'm subtracting the whole thing by 0.5. Okay, the third question is we have an amplitude of 3, a period of 180 degrees, and we're to write down the equation and draw the graph. Now, you drew the graph perfectly, so I don't need to go over that. That has an amplitude of 3, that has a period of 180 degrees. Now, writing down the equation, there's just 2 things you have to do, and you did one of them perfectly. Let's say you want to base this on y equals sine x. As you know, y